Hi ma'am, this is M. Monica from EEE department and roll number 234G1A0261 and my topic is block diagram description of a DC power supply. Outline: Introduction to DC power supply. Block diagram overview: Input stage, rectification stage, filtration stage, voltage regulating stage, output stage. Example of block diagram. Advantages of DC power supply. Conclusion. Introduction to DC power supply. A DC power supply is an electronic device that converts AC voltage into a stable and continuous DC voltage. It is widely used in various electronic systems. The block diagram of a DC power supply consists of several key components that work together to regulate and deliver the desired DC voltage. Block diagram overview. The block diagram of a DC power supply typically includes an input stage, a rectification stage, a filtering stage, a voltage regulation stage, and an output stage. Each stage plays a crucial role in converting and regulating the input voltage to provide a constant and stable DC output. The flow of power and signals is indicated by arrows in block diagram. Input stage. The input stage of a DC power supply is responsible for accepting the AC converter. AC input voltage from the mains or a transformer. It as usually includes a fuse and electromagnetic interference EMI filter and a power switch to protect the power supply and eliminate noise from the input source. The input stage ensures that only the desired AC voltage enters the power supply. Rectification stage. The rectification stage converts the AC voltage from the input stage into a pulsating DC voltage. It typically consists of a diode bridge rectifier which converts the alternating current into a unidirectional flow by allowing current to pass in one direction only. The rectification stage eliminates the negative half cycle of the AC voltage, resulting in a pulsating DC voltage. Filtering stage. The filtering stage smoothes the pulsating DC voltage from the rectification stage to obtain a more stable DC voltage. It uses one or more capacitors to store and release electrical energy effectively reducing the ripple voltage. The filtering stage ensures that the output voltage remains relatively constant and free from fluctuations. Voltage regulation stage. The voltage regulation stage of a DC power supply controls and maintains the desired output voltage regardless of variation in the input voltage or load. It typically includes a voltage regulator such as a linear regulator or a switching regulator to regulate and stabilize the DC voltage. The voltage regulation stage ensures that the output voltage remains within specified limits and provides a constant source of power. Output stage. The output stage delivers the regulated DC voltage to the load or the electronic system being powered. It may include additional components such as protection circuits, current limiting circuits, and voltage indicators. The output stage ensures that the regulated DC voltage is safely and efficiently delivered to the load. Example block diagram. Here is an example block diagram of a basic DC power supply. Input stage: fuse, EMI filter, power switch. Rectification stage: diode bridge rectifier. Filtering stage captures voltage regulation stage, linear or switch regulator. Output stage, load protection circuits. Your second bullet and your third bullet. Advantages of DC power supply. DC power supplies offer several advantages, including stable and regulated DC voltage output, protection against voltage fluctuations and noise, efficient power conversion, customizable output voltage and current, compatibility with various electronic systems and devices. Conclusion. In conclusion, a DC power supply is an essential component in electronic systems, providing a stable and regulated source of DC voltage. The block diagram consisting of the input stage, rectification stage, filtering stage, voltage regulation stage and output stage illustrate the various components and their functions. Understanding the block diagram of a DC power supply is crucial for designing, troubleshooting, maintaining electronic systems. Thank you.